Hi everybody, in this video I'm going to go over some mole conversions to study for our test. Okay, let's take a look at this first one. How many moles are in 4.35 grams of nitrogen? So in this case, I always write down my given value is that 4.35 grams. And I'm trying to convert that to moles. And whenever I have something in grams, I need to find the molar mass using the periodic table. So I'm going to look for nitrogen, which is right here. And we can see the molar mass down there at the bottom is 14.007. So that means for nitrogen, 14.007 grams equals 1 mole. And this is my conversion factor. So now I have my given, and I have my conversion factor, so I'm going to set up my train tracks. As usual, my given value goes in the top left, 4.35 grams. Don't forget to include the unit. You will get confused if you don't. Then I'm going to use my conversion factor, and I want grams to cancel. So since grams is on the top, that means grams also has to be in the bottom. So this is my conversion factor. The number with the grams is 14.007. So that goes at the top and 1 mole goes on, the 14.007 goes on the bottom and 1 mole goes on the top. Now, we put this in our calculator, multiplying by the top and dividing by the bottom. Our grams is going to be canceled, and we're going to be left with moles, which is what we wanted. So in my calculator, I'm putting 4.35 times 1 divided by 14.007, and I get an answer of 2.17 moles. So whenever we're converting between moles and grams, or grams and moles, we are going to first find our molar mass using the periodic table and use that as our conversion factor. Then we'll put our given in the top left, making sure to use our conversion factor so these cancel. In this case, it was grams on top, so grams has to be on the bottom. We multiply across the top, divide by the bottom, and we're done. Let's take a look at a different kind of problem. In this case, it says, how many atoms are in 8.7 moles of phosphorus? So this time, we are given moles. So our given value is that 8.7 moles. And we're trying to convert it to atoms. And in this case, our conversion factor is going to be different. So our conversion factor, when we're dealing with grams, we need to look at the periodic table and then figure out the molar mass, because that is determining the grams. But in this case, there's nothing mentioning grams at all, so I don't need to do that at all. In this case, I'm going to use Avogadro's number. That's this 6.02 times 10 to the 23rd. And that's the number of atoms that is equal to 1 mole. And I want you to notice that this is always the same. So it doesn't matter if this is phosphorus, nitrogen, sodium, potassium, anything at all, there's always 6.02 times 10 to the 23rd atoms in 1 mole, always. If you're given different elements and you have something with grams, you have to look at the periodic table to figure out the molar mass, and that's going to be different for elements. But in these kind of problems where there's nothing about grams, you don't look at that periodic table at all, you just know that 6.02 times 10 to the 23rd atoms equals 1 mole. So now I have my given and I have my conversion factor, so I'm going to go ahead and make my train tracks. As always, I put my given in that top left, 8.7 moles. Don't forget to include your unit. And now I'm going to look at this conversion factor. And this time I have moles on the top, which means I want moles to cancel. So I need moles to be on the bottom. And so here I have 1 mole, and that's equal to 6.02 times 10 to the 23rd atoms. So that's what I'm going to put on the top. 6.02 times 10 to the 23rd atoms. Okay? Now, since moles is on top, moles is on the bottom, it's going to cancel. I'm going to be left with atoms, which is what I want. And so I'm going to multiply across the top and divide by the bottom. Now, the only tricky part here is that you want to make sure you're using parentheses appropriately. So in my calculator, I'm putting 8.7 times parentheses 6.02, the exponent key, 23, close your parentheses, divided by 1. And you should get 5.2 times 10 to the 24th. And when you're writing down that answer, don't forget to include that times 10 to the 24th. If you just had 5.2 atoms, that would not be correct. So we notice this is a little different from before because when we're dealing with atoms, we don't need that molar mass, so we don't need to look at the periodic table at all. All right, now let's look at this problem. Now this is the hardest one because this is a two-step problem. Here we have how many atoms are in 9.1 grams of sodium. So again, I'm going to write down my given value, which is that 9.1 grams. And I'm trying to go to atoms. So we notice this is different from that first problem that was trying to go to moles. So when we're trying to convert from grams to atoms or atoms to grams, it's going to be a two-step problem. And the reason we have this is because if we're going from grams, we can only convert that to moles because that's what our molar mass is going to tell us. And then we can convert moles to atoms. The way we convert between grams and moles is to use the molar mass on the periodic table. Okay, that's the number of grams that equals 1 mole. But to go between moles and atoms, you use Avogadro's number. That's 6.02 times 10 to the 23 atoms equals 1 mole. And in this case, it's going to be two steps because we're going to have to go from grams to moles and then moles to atoms. Okay, so we're going to have to find two conversion factors here. The first conversion factor we're going to need is the molar mass. So here I'm looking at sodium. So I'm going to go up to my periodic table, find sodium, and I can see the molar mass is 22.99. Okay, so that means there's 22.99 grams of sodium equals 1 mole of sodium. Okay, so that's our first conversion factor, and that's going to get us between grams and moles. But we can't stop there because we're looking for atoms. So we need to use that second conversion factor. And just like we said before, this one's always going to be the same. It's always going to be 6.02 times 10 to the 23rd atoms equals 1 mole. And it doesn't matter what element it is. Okay? So now we have two conversion factors and our given value. And so now we are going to set up our train tracks. And again, it's going to be a two-step problem. So I'm going to put what I'm given in that top left, 9.1 grams. Now, making sure I include that unit. It's going to get very confusing here if we don't have the unit. So now I look at my two conversion factors, and I find the one that has grams, because I need grams to cancel, so I know I'm going to need something in grams down here. Looking at my conversion factor, this is what I have in grams, 22.99 grams. And that's equal to 1 mole. So I'm going to put 1 mole on top. Remember, whatever it's equal to needs to go right on top of it, or below it. And this is good because now grams will have canceled. But we're not done yet because we're going to be in moles, and we want to go to atoms. So we need to do our second step here. We've already used this first conversion factor. And now we're going to use our second conversion factor to convert between moles and atoms. So now I have moles on top, which means I know something in moles needs to be on the bottom. So I look at the second conversion factor, and the number of moles is 1. And that's equal to this 6.02 times 10 to the 23rd atoms. Okay? Again, things that are equal are right on top of each other. Moles is up here, moles is down here, so they cancel. And I'm going to be left with atoms, which again is what I wanted. So now I'm going to go ahead and put this in my calculator. I'm going to multiply across the top and divide by the bottom. And I'm going to put this all in my calculator at once before hitting that equal sign. So I'm going to do 9.1 times 1 divided by 22.99 times parentheses 6.02, the exponent key, 23, close parentheses, divided by 1. And you should get 2.4 times 10 to the 23rd atoms. And that, again, is going to be my final answer. So we're noticing here, when we're going between atoms and grams, it's a two-step problem, okay? Because we need to use the molar mass to convert between grams and moles. And then we need to use Avogadro's number to convert between atoms and moles, okay? So when you get anything that's between atoms and grams, you know it's going to be two steps, and you're going to need two conversion factors. So today we went over 3 different types of problems that you might see. The first one is converting between moles and grams. When we have that, we're going to make sure we look at our periodic table to figure out the molar mass, and that tells you how many grams is equal to 1 mole. When we're converting between atoms and moles, we're just going to use that fact that 6.02 times 10 to the 23rd atoms is equal to 1 mole, and that's always the case. And so that is going to be our conversion factor when converting between atoms and moles, or moles and atoms. When we're converting between atoms and grams, we know this is going to be a two-step problem because we're going to have to convert grams to moles before we can convert it to atoms. So in that case, we need 2 conversion factors, both the molar mass, which we found on the periodic table. That gives the number of grams that's equal to 1 mole. And again, Avogadro's number, which tells us that 6.02 times 10 to the 23rd atoms equals 1 mole. Then we line this all up so that everything on the top is canceled by what's on the bottom. And that allows us to do a 2-step problem to convert atoms to grams or grams to atoms. Hopefully this was helpful. If you have any questions, please let me know.